Hello students, I am Vishwas, and as part of Ekcel Academy's CSEET classes, we will be now looking into quantitative aptitude. As you can see on the screen, quantitative aptitude is part B of current affairs and other associated topics of CSEET syllabus. This is something which the institute introduced only with this attempt. So until now we didn't have this quantitative aptitude as part of the syllabus, and this is there only for 20 marks right now. Of course, we still have logical reasoning as part of the syllabus where some of the topics actually overlap. Now, when you think of quantitative aptitude, we have only two chapters as can be seen on the screen. One is chapter 6 or lesson 6, which is the number system, and 7, fundamental arithmetical operations. Now, number systems is something which you would be already familiar with. This is mostly theoretical in nature. And fundamental arithmetical operations is also something which you would have already done. Meaning, this is not something which you'll be learning afresh. These are the topics which you are already familiar with. I think this is the only section in the entire syllabus where you would find it easy to understand, because this is not something new to you. For example, when you think of fundamental arithmetical operations, what do we think of? We know that we have addition, subtraction, multiplication, and division. And that entire chapter is based on these 4 operations only. That's all. And number systems is mostly theoretical. As I said earlier, it's all about what is whole number, what is natural number, what is a rational number, irrational number, integer, decimals, fractions, etc. Apart from these two, we don't have anything else in the quantitative aptitude section. You can think of these 20 marks as pure lottery, meaning there is every chance of you scoring 20 out of 20 in this section. No matter how difficult or tough or easy or whatever it is, I don't think scoring 20 should be a Herculean task as far as quantitative aptitude is concerned. Before we proceed with the actual content of the syllabus, let us quickly go through the overview of the syllabus. This is part 4, quantitative aptitude, and the objective as given by the institute is to test the basic understanding of QA and nothing else. That means if you know the basics of this, then you don't have to worry much about this. So they have given us what are the subtopics contained in each of these lessons. For example, in case of lesson number 6, which is the number systems, we have the subtopics of computation of a whole number, decimal and fractions, relationship between numbers, as I said, theory. Then comes chapter 7, which is fundamental arithmetical operations, wherein we have percentages, ratio and proportions, square roots, averages, interest, simple and compound interest, profit and loss. As far as the last 2, 3, 4 topics, they haven't given much in the material. So I'm not so sure if the institute will ask too many questions regarding those, but in any case, we'll be solving problems related to those as well. Okay. So now that we have had a brief overview of the subject, or rather the part of the subject, and also had a look at the subtopics of the syllabus, now we can directly get into the lesson itself. Now, if you look at the text there in the first part of the QA, what do they say? A number system is an arrangement of expressing the numbers in written form. Digits and symbols in a consistent manner are used in a number system. All the numbers are represented in the arithmetic and algebraic structure. The number system, among other things, facilitates addition, subtraction, multiplication, and division. This, you can think of this as an introduction or gist of what all the number system does. If we have to go into the details, it would be like this. First of all, they talk about the arrangement of expressing numbers. A number system is essentially, what is it? It's essentially a method, or you can say an arrangement for representing numbers in the written form. So we have an order here, wherein it's a predefined order. It's not something which we found out just now. It's been in use since a long time, and it provides a structured way to express numerical quantities. We cannot express quality in terms of numbers, whereas we can express quantity in terms of numbers. For example, if you have a let's say you had a very good dosa somewhere and you liked it, you can't express this in numbers. Whereas if someone asks you, how much did you pay for the dosa or dosa, then you will obviously be able to answer that because it is expressed in terms of numbers, which are in order. So that is what they're essentially trying to tell us. And digits and symbols in a consistent manner, they say. So what exactly they are referring to? In a number system, there are specific digits and symbols that are used consistently. That means when a particular digit is used, we know what exactly it is referring to. Its meaning or its whatever it quantifies, it won't change. These elements will have predefined values and meanings, ensuring what the uniformity in representation. So that is what we mean by digits and symbols in a consistent manner. Then they also talk about the arithmetic and algebraic structure. See, what you have to understand is number system is not an isolated entity. They're organized within a framework that supports both the arithmetic as well as the algebraic structure, or rather the arithmetic and algebraic operations. This means what? That number system is designed in such a way so as to handle the basic mathematical operations like addition, subtraction, multiplication, division. So it facilitates all these operations. Whether you are adding, subtracting, multiplying, or dividing, the structure of the number system allows you for systematic and consistent computation. It will never deviate. No matter who calculates, the answer will still be the same because we are working based on set or predefined system. Okay. So that was the introduction. Now let us look at the types of numbers. We have different types of numbers here. Let us see what each of these actually mean. Now let's start with the first type of numbers, which is the natural numbers. The name itself actually tells us what exactly they refer to. See, natural numbers by definition are a set of positive numbers that start from 1 and it continues indefinitely. There is no end to it. Only the starting point is known and not the end point. So you can think of any number. If you add 1 to that, the natural number will extend obviously. That's why we say it goes on and on and on indefinitely. But it starts from 1. Now, why are they referred to as natural numbers? See, if someone asks you, for example, let's say, count the number of oranges in the basket, then what would you do? I would be like, okay, 1, 2, 3, 4, 5, 6, 7, 8. Count the number of students in a class. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, where do we start it from? We start it from 1. These are all integers, positive integers, which starts with the number 1. So we don't say 0, 1, 2, 3. We say only 1, 2, 3, 4. So that's why it's a natural process of counting. That's why we refer to as natural numbers. And it's something which we use in everyday life also, no? So, for example, they are used for counting items, telling time, expressing quantities, and various other real life situations which you can think of. So, but one thing which you have to remember here is one of the properties of natural number is there is no greatest natural number. Any number which you can think of, if you add 1 to it, as I said, that will be the next higher natural number, no? So, therefore, the greatest number you can think of would be n plus 1. Whatever that n is, plus 1 will again continue the natural number. So they have given few examples like what are the basic operations which we can do with natural numbers. 4 plus 2, of course, these are all addition. We can do any operation with respect to natural numbers. Addition, subtraction, multiplication, everything works. But one thing which we have to be sure of is it should be a positive integer. For example, let's take this example only. 2 minus 6. 6 minus 2 is obviously a natural number 4, positive integer. Whereas if I reverse this, then it won't result in a natural number, because then I would be looking at 2 minus 6, which is nothing but minus 4. Minus 4 is not a natural number. It's not a positive integer. We'll come to integer as well in a second. Okay. So 4 plus 2 of course is a natural number. 6 plus 21, yes. 22 minus 6, of course we know that. Multiplication also works. 4 into 3, 12, and 12 into 3, 36. So now they are talking about the fundamental operations with respect to natural numbers. We can do addition, subtraction, multiplication and division. For example, 12 divided by 6, obviously it will result in a natural number, whereas not all division, not all subtraction will lead to natural numbers. For example, 6 divided by 4 is not a natural number because it results in a fraction, or in other words, decimal. When that is the case, we are going beyond the definition of natural number. It has to be something which can be expressed in multiples of 1. This cannot be expressed like that. So therefore, that would not be a natural number. So that means what? If there are a set of natural numbers, you can perform the operation of addition, you can perform the operation of multiplication, which will invariably result in another natural number. Whereas, if you have a set of natural numbers and if you perform the function of subtraction and division, it need not always result in a natural number. Sometimes it will not result in a natural number. Okay. So that is the thing which they are mentioning here. Okay. So the next is the whole numbers. Okay, let's elaborate on the concept of whole numbers, particularly addressing the inclusion of 0 and their characteristics. So now, when you think of natural numbers, we know it's all positive numbers starting from 1 and continuing indefinitely. However, when you subtract, let's say, a natural number from that number itself, the result is always 0. For example, let's say 10 minus 10. Both are natural numbers, and when I subtract this number from this number or whatever, so the answer would obviously be 0. So now there was this confusion. Now 0 is not a natural number, but if we don't include 0, then it won't be complete also. So to address this challenge, what they thought was, let us do one thing. Let us keep natural numbers as it is and instead form a new category called the whole numbers, wherein we will include the 0. So that means what? Apart from this inclusion of 0, whole numbers are nothing but the natural numbers only. Okay. So this extension of 0 resulted in a new system called whole numbers. So that means what? Whole numbers includes all the natural numbers along with 0. And natural numbers are denoted by n, whereas the whole numbers are denoted by w. That's the way it is denoted. And one more thing, whatever applies to natural numbers will apply to whole numbers as well. For example, we cannot include fractions, there cannot be negative numbers, there cannot be decimals. All these rules which are applicable there will also be applicable here. Again, one more thing which we saw there was, there is no such thing as greatest natural number. Same thing applies here too. There is no such thing as greatest whole number. Any whole number you can think of, add 1 to it and you will get the next greatest whole number. So once again, for what do we use whole numbers? Same thing as we use natural numbers: counting, measuring and various mathematical operations. So that is the thing with respect to natural numbers. And of course, division by 0 is not defined, they say. That means, think of any natural numbers, let's say 5. 5 divided by 0 is not defined at all, because there is no way any number can be divided by 0. Whereas 0 divided by 5 is easy to answer, because 5 into 0 is anyway 0. So therefore 0 divided by 5 is 0 itself. Whereas the vice versa is not true. So if at all you get a question wherein they say division by 0 of a natural number or a whole number, then your answer should be not defined, not 0. And again, they have given a diagram here wherein you can just see the whole numbers being represented in a line starting from 0 and proceeding towards infinity. N plus 1, that would be the last natural number. Okay. Of course, these are not natural numbers. Minus, if there is any negative sign, they would not come under the natural numbers category. So that is the thing with respect to natural numbers. Let's do one thing. Let's move on to the next topic, which is the integers. How did they come about integers? See, when we are working with one particular thing, or in this case natural numbers or whole numbers, or rather when we didn't have all these things, or when maths wasn't advanced as it is now, they probably realized that there is some limitation here, basic limitation with respect to natural numbers and whole numbers. In case of natural numbers or whole numbers, let me just say whole numbers because whole numbers anyway includes natural numbers. In the system of whole numbers, subtraction is not always straightforward. For example, if you try to subtract a larger number from a smaller number, for example 5 minus 7 or 6 minus 14, 18 minus 38, the result is not always defined with the existing number system. For example, let's say this and this. These are the examples which I considered right now. Now what would be the result of that? 5 minus 7 minus 2. Where will you see this in the line of natural numbers? Because natural numbers or whole numbers, it starts only from 0. Same thing with 6 minus 14. So this is something which I cannot fit there, no? So that is the reason why they perhaps thought that we need something else which can extend the number system to handle these situations where subtraction is not possible with the natural or the whole numbers. They thought we need an extension of the existing number system. So as a result of that thought, we have something now known as integers. Negative numbers denoted with a minus sign, they were introduced to allow for these type of subtractions. Now okay, now that we know that 5 minus 7 is minus 2, it cannot be a natural number, it cannot be whole number. Therefore we introduce something known as integer, which also includes which includes whole numbers, and along with that it also provides for negative signs. So that's how integers were introduced. And also with respect to multiplication, whole numbers can be multiplied by negative integers such as, let's say, minus 1 or minus 2, and this will result obviously in negative integers. For example, 10 is a whole number. If I multiply by minus 1, which is a negative integer, the result will be minus 10. This is obviously not a whole number, this is not a natural number. So what is this? This is a negative integer. So that means what? Integers will include positive numbers, 0, as well as negative numbers. Okay, so the set of integers is usually denoted like this, kind of Z symbol. So with respect to multiplication, we saw that even when you multiply by minus 1, you can still have that number, and that will be denoted by integer. And also with respect to subtraction also, now we can subtract a larger number from a smaller number, so that will also result in a integer. So this is how an integer can be represented in a line of numbers, where starting from this part it is the whole numbers, whereas all put together would be considered as integers, because integers includes everything. So again the same thing. So various points they have mentioned, nothing great there. So the rest is what we have discussed so far. There are few examples which are mentioned here, kind of an exercise, simple ones. Let's just look at this. First one, classify natural numbers, whole numbers and integers among the following. We have 15, 22, minus 6. The moment you see minus 6, minus 7, minus 13, whatever, you can easily identify that is not a whole number, that is not a natural number. It can only be an integer, because only integers will include the negative numbers. So now let us start with the natural numbers. So natural numbers is easy to identify because we know for a fact that it is nothing but a positive number excluding the 0. So now if I have to zoom this, 12 natural number, 13 natural number, 7 is a natural number, 22 is a natural number, 15 is a natural number. So these are the only 5 natural numbers which we have in this set. So that is with respect to the natural numbers. Now whole numbers would be much more easier because we have already defined the natural numbers, which are these. Now to that add just this 0 and you will be done with the whole numbers. And when it comes to the integers, whatever is included here, that is in whole numbers, will be included in integers as well. On top of that, we will also include the negative numbers. So which would be the negative ones, minus 6, minus 13, minus 12, minus 31. These would be added to the set of whole numbers which are already defined here, and then we will get the integers. So okay, they have surmised something. Let's see. All natural numbers are whole numbers. Of course, yes. And integers, natural numbers are whole numbers and also integers at the same time. But all integers need not be whole numbers, all integers need not be natural numbers. Okay, and all whole numbers are also integers, they say. That is also true. Simplify the following and indicate whether or not the outcome is an integer. Okay, 12 into 4 obviously is an integer because 12 4 is 48. 7 by 3 is a fraction. Fractions are not part of the integers, so therefore we'll have to simply ignore this. This is not an integer. 18 by 3 fraction 36 by 7. Okay, 18 by 3 we can still consider. So even though it is a fraction, it can be simplified, no? So 18 by 3, since the question itself is about simplification. So 6 would be the simplified form of 18 by 3 because 3 times 6 is 18. So this is an integer. 36 by 7 not possible, whereas if it was 35 by 7 it would be possible. The simplified form of that would be 5 and 5 would be an integer. Then we have 14 into 2, obviously an integer. Both are natural numbers. When two natural numbers get multiplied, it will result in a natural number only. Okay, and of course any natural number is also an integer. 18 by 36 is not possible, whereas 36 by 18 would be an integer. 18 by 36 will simply result in a fraction, decimal, whatnot, whereas 36 by 18 would have resulted in 2, which would be a natural number. And 13 multiplied by minus 3 is also a natural number, because we know any whole number which is multiplied by integer will result in an integer itself. So therefore 3 is an integer, minus 3, and that is multiplied by 13. So 13 into 3 is 39, but in this case it is a minus 39, which is also part of the integer. So that's how we decide. Let's move on. Using number line, add the following integers. Again, you don't have to worry about these type of questions in the exam. You will obviously not get this. This is only for your understanding. So we have a number line starting from minus 7 ending with 9. So what do they say? Add minus 5 to 9. That means whatever is this is the 9. From that we have to remove 5. So when you do that, what you will be left would be nothing but 4. 9 plus minus 5. So minus into plus would be minus. 9 minus 5 would result in 4. For example, when you do that, how have they represented this? 1, 2, 3, 4, 5. Okay, what is left is 1, 2, 3, 4, like that. I don't think it's proper representation, but anyway. Okay, let me just read whatever they have written here. At A represents 9, okay, fine, on the number line. Going 5 units to the left of A, okay, we reach point B, okay, fine. 1, 2, 3, 4, 5, which represents 4. Okay, like that. Okay, nice, got it. So 1, 2, 3, 4, 5, and whatever is left would be 4. That way also we can actually identify the operation. Basic operation, subtraction, that is. Then what else? There is one more here, minus 3 and minus 7. So we have minus 3 here, and then we have minus 7 here. So when both are added, sorry, minus 7 starts from here. When both are added, you will get minus 10. Okay, point A represents minus 3. Point B, or rather A to B, represents minus 7. When you add both, you will get this. That is from this point to this. So we know for a fact that minus 3 plus minus 7 is nothing but minus 10. So that is what we have here. Again, it's all elementary stuff, not required for you guys. Okay. So that finishes our topic of integers. Next is the rational numbers. Until now, we haven't entered the area of fractions. We have been looking at natural numbers, whole numbers, integers, but not the fraction. We have even covered the negatives and that is integers. Now, what is this rational number? As I just now said, it's a number which can be expressed in the form of a fraction or the quotient of two integers, where the numerator is an integer, the denominator is also an integer, but there is one condition, which is the denominator should be a non-zero integer. In other words, it can be written in the form of, as seen in the screen, a by b. One more thing which I wanted to mention, I have deviated from the institute notes because I think that is slightly confusing with respect to the way the material is worded. They have directly copied from some other source material. They have given the links of the same as well. If you want, you can check the source material, but I don't think that is required either. Anyway, coming back to the point, a rational number can be expressed in the form of a by b. A divided by b, of course, where both a and b are integers, but b should be a non-zero integer. That's all. As long as that condition is fulfilled, then there is nothing much to do here. So let us look at the characteristics of this rational number. A rational number is essentially a ratio. Of course, it is expressed in the form of a fraction or quotient of two integers. The numerator and the denominator can be positive, negative, or 0. Of course, this or 0 applies only for the numerator part, not the denominator part. For example, 5 by 4 is a rational number. 3 by 4 is also a rational number. Minus 3 by 4 is also a rational number. Okay, so this is also a rational number, but this is not a rational number. Denominator cannot be 0. It will be undefined then in that case. Form of a rational number, of course, we just now saw. Form is nothing but how it is expressed. It is expressed in this form. Examples, of course, these are common examples. 3 by 4, it is nothing but 0.75. Then minus 5 by 2, 0, 7 by 1. Some examples, there are few things which they have mentioned here. Negative 5 divided by 2 is also a rational number. Yes, it is. 0 can be expressed as 0 by 1, which we saw. As I said, this is a rational number, whereas this is not a rational number. Okay. Integer can be expressed as a fraction with the denominator of 1. That means any number, for example 55. This can also be expressed in the form of a fraction when you just divide that by 1. So just put 1 denominator, 1 as the denominator, then you will be getting a rational number. Negative 2 divided by 3 is another rational number. Okay, there are various examples. You can just go on and on and on with respect to the examples. Moving on, the other characteristics. Terminating and repeating decimals. See, in case of fraction, decimals is something which is unavoidable. Decimals will be there. For example, we'll take this only. 1 divided by 4, 1 divided by 4, 0. Point, because 1 cannot be directly divided, so I will borrow one 0 here. 4 2s are 8, 2 is the remainder. Again, since I have already put the decimal here, I can put one more 0 here. So 4 5s are 20. So that means it's a terminating decimal. So that means we are done with the division of 1 by 4. We already have got the answer, 0.25. In some cases, what happens, this will not be the case. For example, 1 divided by 3, 0 point, we will get 0. 3 is 9. 1, again same thing. It will go on and on and on forever. We can just go on, it will never end. So that means what is it? Repeating decimal. Same thing is getting repeated or recurring. That is with respect to terminating and repeating decimals in rational numbers. Then since we are looking at terminating or repeating decimals, we can also have a look at the irrational numbers at the same time, because irrational numbers are not very different from the rational numbers, but here what happens, whatever is the result, you can't get in the form of a fraction. For example, root of 2, whatever is this, for let me just try to do this, 2 square root, I don't have the root function, yeah I have. See, look at this answer, 1.4142135623. It will go on, of course, the calci doesn't have so much space, but can you see if there is a pattern here? Is it repeating? Of course not. Is it terminating? Of course not. So this is referred to as an irrational number. Or you can even think of a pi, that is 22 by 7, 22 divided by 7. This will go on and on and on. For example, 3.14285714285. It will just not repeat, not terminate. So that is referred to as irrational number. Again, with respect to rational numbers, we can obviously do all these arithmetical operations like addition, subtraction, multiplication and division, and of course result in another rational number. So that's all about the number system as such. We'll be looking at different problems, different aspects, computation of numbers in the next part.